Okay, hello everybody. Let's start the warm-up. I'll give you 3 minutes on this and then we'll go over it when the bell rings. Okay, let's go over simplifying these. Remember, if we're going to simplify radicals, we want to look for perfect square numbers that are factors of the radicand. That's the number underneath the radical sign. So for this first one, I'm going to look at the radical 160, and hopefully you can quickly come up with that is a product of a radical, whoops, here we go, radical, if I can get my pen to write here, radical 16, radical 10. And then I'm going to simplify that down to a 4 radical 10. And I'm going to subtract from that, simplifying this radical negative 147. I want to write that as a radical negative 1. And then hopefully you were able to find that if I multiply 49 times 3, that will give us the radical 147. So and I'm just going to simplify this. This radical 16 becomes a 4, and I get 4 radical 10. My radical negative 1 I want to replace with I, the 49 with 7 outside a radical sign, and I want to write that out in front of my I. So right now I'm subtracting 7i outside a radical, and then a radical 3 still under the radical there. So my final answer there boxed in for you. Number 2, I want to rewrite that as a radical negative 1, And then if you want to separate the 16 and the b to the 6, we can write it as radical 16 radical b to the 6th. When I simplify that, my negative 1 under the radical becomes I, and then I've got a 4, and then I've got a b to the 3rd, which is the square root of b to the 6th. When I write this out, though, I want to put the I last, so I'm going to write 4b to the 3rd I, and that's final answer on that one. Number 3, I've got an expression I'm subtracting. Radical 25b I can break down as radical 25 radical b minus the 48 I can break down into a 16 times 3, and the b squared is itself a perfect square, so that's going to become radical 16 radical 3 radical b squared, taking out the square roots there. I'm going to end up with, from the first term, 5 outside the radical sign, radical b, minus, outside my radical can come a 4 and a b for the second term, and then radical 3. No i's involved in that answer. Alright, moving on to number 4, 2i times 3i. Remember, I can use commutative property of multiplication, and I can write this rearranging the order in which I multiply. So I can write this as 2 times 3 times I, which becomes 6i squared. Now remember, I squared is equal to negative 1, so this product becomes 6 times negative 1, or negative 6. And that's the final answer on that one. Alright, so we're going to look at some new notes today. So I want to turn the page, and we're going to start to look at what's called complex numbers, and then we need to know how to add them, subtract them, multiply. The divide part, let's see if I can get my pens again. Divide part, not something that is part of this new Common Core curriculum. This is actually within the old curriculum. So even though I've given you some notes with how to divide complex numbers, not something that I'm going to test you on for this unit. However, if you're planning on taking the old test, hopefully you are, we will be learning how to divide those complex numbers. But for now, let's go ahead and turn our pages on our notes and look at what these things are called complex numbers. Okay, complex numbers. Basically, they have I in them. So I have typically two parts to a complex number. I have what's called the real part, represented by A, and the imaginary part, represented by I multiplied by some coefficient. So this part here is the imaginary part. The A is the real part. Remember yesterday when we plotted an answer that we got to a quadratic, we had an answer where x was equal to negative 1 plus and minus 2i, which is really two answers. The first one I can call x1 being negative 1 plus 2i. The second one I can call x2 being equal to negative 1 minus 2i. So for that answer, A is represented by negative 1. That's the real part, and that's where I move on the real axis when I plot these. And then my imaginary part, or the B part, for x1, B equals 2i, or the B part is actually just the 2. For x2, B equals a negative 2. Thus I have the negative 1 plus 2i and the negative 1 minus 2i. So we need to look at how are we going to add and subtract these things, and then how are we going to multiply them. So I'm going to make sure that you know a couple things to remind you. Remember, I is equal to the square root of negative 1. When we have complex numbers, we have two parts, a plus bi. A is the real part, BI is the imaginary part. Alright, so turning our pages then. I need to know how to add these complex numbers. All I really have to do is take the real parts, add them together, and then take the imaginary parts, add those together, and make sure when I express my answer I put the real part first, the A part comes first, followed by the B times I part. So, looking at this example, I have 6 is my real portion for 6 plus 3i, and I'm adding that to 5 minus 3i. 5 is the real portion. So I can express this sum as adding my real parts together, 6 plus 5, and then I'm going to add the imaginary parts. That would be the 3i and the negative 3i. So I'm going to add my reals, and I'm going to add my imaginaries. 3i plus a negative 3i, which is going to give me a total of 11 plus, now 3i plus a negative 3i is going to cancel out, and I have 0i, but I can write that as 11, which is entirely a real number, but still a complex number in that it can be expressed as 11 plus 0i. So that's enough on adding those. Let's go and look at how we're going to subtract these things. I'm sure you've got it guessed by now. We're just going to take our real parts, combine those, then take our imaginary parts, combine those. So for this next example, taking my real parts, this time I'm subtracting, so I'm going to take my 6 and I'm going to subtract my 5. That's the real part. And then I'm going to distribute. Now when I put my negative sign with a negative 3, I'm going to end up adding it. But I'm going to take my real parts and combine it. I'm sorry, my imaginary parts and combine it. So I've got 3i subtracting a negative 3i. So this now is the imaginary part. When I put these together, then I'm going to have 6 minus 5, or 1, plus 3i minus a negative 3i gives me 6i. In this case, I have a real part and an imaginary part to my complex answer. Okay, let's go on to the next page. Talk about multiplying these complex numbers. These complex numbers have the two parts, the real and the imaginary, so when I multiply them, I need to distribute every part to every part. The easiest way to do that is to use that box method for multiplying. Some of you still like to think of it as foiling. I'm going to write it out using our box. I'm multiplying 3 and a negative 4i with 2 and 5i. So filling inside my box, 2 times 3, 6, 2 times negative 4i. When you're multiplying these, you might want to think first about what is the sign of your product. So for this next box that I'm going to fill in, 2 times negative 4i, I'm going to think of it as multiplying a positive times a negative, gives me a negative. And then the 2 times 4 is 8, and I have I. Next box, positive times positive is going to be a positive, 15i, and then a negative times a positive, going to give me a negative, 4 5s is 20, and then I have I squared. Now remember, I squared, I'll write this off to the side, is equivalent to negative 1, so I'm going to need to do some more simplifying. Combining my like terms, these two boxes are still going to be like terms, so what I've got so far is 6 minus 8i plus 15i gives me plus 7i. And then I've got this minus 20i squared, but I want to replace my I squared with a negative 1. So this becomes 6 plus 7i minus 20, which is really multiplied by negative 1, or 6 plus 7i plus 20. So my final answer turns out to be, when I combine like terms, 26 plus 7i, and this is written in a plus bi form. So the real part first, followed by the imaginary part. All right, let's take a look at the next example. This time I've got 4 plus 5i being multiplied by 4 minus 5i. Hopefully you're going to notice something about these two binomials. Hopefully somebody's saying, oh yes, that is product of two conjugates. So 4 plus 5i is a conjugate of 4 minus 5i, which means when I multiply these two binomials, my two middle terms should end up canceling each other out. So I'm going to go ahead and draw myself the box on this thing. Okay, so now filling in, I'm going to get 16, 20i, negative 20i, and then positive times a negative gives me a negative. 5 times 5, 25, I times I squared. My middle two terms are going to cancel out because I've got product of conjugates here, so those are gone. My terms that are left, 16 and a minus 25, I squared. But again, remember, I squared is equal to negative 1. So I want to take my 25 and multiply it by negative 1, which will be, in effect, taking 16 and adding it to 25, which gives me a final answer of 41, if I've added that correctly. So final answer on that one, 41. All right. Let's do a few practice ones. What I'd like you to do is work on these on your own. I will at the same time write out what I get doing these, and you can check your answers as you go along. Also probably a good time, especially if this is 7th period class, just a reminder, please make sure all phones are put away. All right, I'll work on these. You work on them at the same time, please. Okay, hopefully you've had a chance to work on those and check your answers. If not, you can pause and scroll back up to see the answers that have already gone by. What I'd like to do now is have you take a look at the next page. Now this page is not in your notes, so please watch carefully. I could not put the TI Inspire software right onto this recording, but I did take a snapshot. If you can find the I button in your TI Inspires, and by the way, Jack Flanagan showed me a shortcut to getting that. If I go to my TI Inspire and over on the left-hand side, I press the button that has Pi on it, if you notice there's a little arrow on that thing, brings up a menu. And on that menu, you can quickly choose the I on there. So a little bit faster than what I showed you yesterday, which was going to that library book button and then going to chapter 3 and then finding your I button there. But anyway, here's what I'd like you to notice. I can take and manipulate I in all kinds of expressions right from the calculator. This problem right here is one of the ones from your homework. It's on the first page, letter D. I put that in the calculator just as it is on my homework, and these Inspires really nicely give me the answer here already in A plus BI form. So 16 plus 12i. You do still need to know how to add and subtract these and how to multiply them, but this gives you a head start on the homework. If you could use the rest of the time to work on that homework. And also there's a ticket out the door for you. I would like you please to do your best on those so that when I come in and take a look at what you did yesterday, or it will be yesterday for you, I can quickly see how you did. Thanks a lot, guys. Have a great day. Bye-bye.